Welcome to Burlap Teachers. Enjoy the video.
You start by preparing an environment that's reproducible and minimal. Create a virtual environment, install NumPy, Pandas, scikit-learn, and Jupyter. This keeps dependencies clean. Load your dataset, inspect columns, and define the target variable so you understand labels versus features. Once done, convert types, handle missing values with simple imputation, and split into train and test using an 80/20 split. These immediate actions get you into modeling quickly, so you can iterate without wasting time on heavy setup. You construct a pipeline that chains preprocessing and modeling so transformations are consistent across folds. Use simple imputer, standard scalar, and one hot encoder inside column transformer to handle numeric and categorical data. Fit a baseline model like logistic regression for speed or random forest for nonlinearity. This gives a performance floor. Then use grid search CV or randomized search CV with cross-validation to tune hyperparameters. This saves you from overfitting and reveals robust settings. Make sure to persist the best pipeline. You finalize by evaluating on the held-out test set using ROC-AUC and precision/recall to capture class balance issues, and plot a confusion matrix to inspect error types. Once satisfied, save the fitted pipeline and environment via joblib and requirements, TXT or Conda environment, IML. Then write a small inference script or wrap the pipeline in a lightweight API for deployment. If things go wrong, quickly check for data leakage, mismatched D-types, or distribution drift between train and test. Correcting those usually resolves most failures.
Thanks for watching. Consider subscribing if this video helped you.